All right. Yo, yo. This is Gradius, and we got a video here for 6.1, part one, talking about algebraic expressions. So there's going to be a lot of vocabulary in this particular section and in just in this unit in general because we're reviewing some stuff that we didn't necessarily, that you might have missed last year in sixth grade. So we're kind of going to go over some sixth grade stuff and some seventh grade stuff all at once. So we're going to talk about variables, coefficients, and like terms. So a variable is a symbol used to represent a quantity that can change. So variables are generally letters. We use X a lot for a variable. We use Y a lot for a variable. We'll use M a lot, but X and Y are probably the two most common, but it really can be any letter. A coefficient is a number that is attached to the variable or multiplied by the variable. So if you see something like 4x, this number 4 is the coefficient. 5y, the number 5 is a coefficient. So those would be examples of coefficients. And like terms, this is the big one today. So the like terms are what we're going to talk about the most. And those are terms with the same variables raised to the same exponents. So if I have an algebraic expression where it's something like 4x plus 5x plus 3. So that would be an algebraic expression. I don't have an equal sign, so that's what makes it an expression. We're going to talk about like terms a lot today, but the like terms would be 4x and 5x, okay, because they are terms with the same variables. So they both have an x. This 3 right here does not have an x on it. So therefore, it does not have the same variable. It is not a like term. So those are examples. And then we're going to look at a lot of these here right now. So what you're going to have to do is you're going to have to simplify algebraic expressions. And the way we do that is we do it by combining our like terms. So what we see here is for this first expression right here, I have 24x plus 14 plus negative 14x plus 12. So what we're doing here is we are going to simplify this to make it not look so complicated. I got all these parentheses. I've got 1, 2, 3, 4 different terms. And we're going to simplify that to hopefully just to have 2 terms is our goal here. To make it just look a lot more appealing to the eye, look a lot more simple. So that's why we're going to simplify it. So what I want to do is these parentheses really actually don't matter. I know PEMDAS says we have to simplify the parentheses first. Well, if I'm looking at these parentheses, is there anything I can do inside the parentheses? So if I'm looking at just 24x plus 14, is there anything I can do with this? And the answer is no, there is not. And the reason why is I am not allowed to combine 24x with 14 because they are not like terms. So I am not able to combine these. I am not able to make them 28x. We are not allowed to do that, okay? And the reason why is because this doesn't have an x attached to it. What this is saying is I have 24 x's and then I just have 14 regular numbers. So therefore, if I have 24 x's and 14 non-x's, I can't combine it and say that's 28 x's. It just doesn't make sense. So we're not allowed to do that. Now, we don't know what x represents here. We're not exactly sure. X represents, it's a variable that represents a number that could be any number. We have no clue what it is. We haven't been told what it is. So therefore, I can't simplify this at all because I don't know what x represents. So therefore, this is completely simplified, this 24x plus 14. Now, same thing over here with the negative 14x plus 12. I have an x, I have a non-x. So there's nothing I can do inside of here because those are not like terms. So I cannot combine them together, which is what we're going to work on right now. So therefore, there's nothing I can do inside of these parentheses. So what we're going to do is the parentheses don't really matter. So I could even rewrite this without parentheses. So this is really 24x plus 14 plus, that's negative 14x. I'm going to put that one thing in parentheses to separate the plus and negative sign. Plus 12. So what I'm going to do is I'm going to look for like terms and then I'm going to combine them. So I have 24x here and I have a negative 14x here. So because I have a 24x and a negative 14x, I can combine 24x's with 14 negative x's. When I combine those, I'm really just adding or combining the coefficients. I'm combining the 24 with the negative 14, and then the x is going to stay the same. So it's basically like saying I have 24 x's, I have negative 14 x's, how many total x's do I have? Well, if I combine 24 and negative 14, it's just going to give me 10. So these combine to 10, and I still have the x of it attached to it. So 24x and negative 14x makes 10x. Now I also have 14 and 12 as well. Okay, so 14 and 12. I'll do these ones in triangles. Maybe that'll help kind of separate them. So I can combine 14 and 12. So that's 14 positives, 12 positives. We carry the sign with the value there. Okay, so because there's a positive sign in the front of the 14, it's positive 14. So 14 positives and 12 positives make a total of 26 positives. I am done. I have simplified this expression fully. There's nothing else I can do. I combined my like terms, and I have 24x and negative 14x makes 10x. 14 and 12 makes positive 26. There's nothing else to do. That is my final answer. That is a simplified expression. And I did that by combining like terms. Don't know what x is, so I can't go any further. I cannot combine those to make that 36x because there's no x attached to this 26 right here. So the second one here is the same thing, but now we have y's and x's, and that's okay. Y is a different variable than x. So therefore, I cannot combine y's with x's. If I said I had negative 17 y's and 14 x's, I can't say I have negative 3 x's because then I'm forgetting about the y's. So we cannot combine those with each other. So again, what we're going to do is we're going to focus on combining our like terms. So I'm going to look to see, do I have any other y's to combine with this negative 17y? I also have positive 12y. None of these other terms have a y involved. So what I'm doing is I'm combining negative 17 with positive 12, and then I'm going to keep the y there. So negative 17 and positive 12, when I combine negative 17 and positive 12, I'm pulling this off to the side real quick. And I got to look, okay, I have more negatives than I do positives. I know my answer is negative. Different sign, so I'm subtracting the numbers. So I'm left with negative 5. So that's going to give me negative 5. And then I keep the y attached. So that's negative 5y. Now let's look at my x terms. I have positive 14x, and then I have a negative 8x. So remember, we keep the sign. I know that we're saying with Mr. G, that's a minus 8x. Well, the minus sign looks like a negative because it represents the same thing. So that's positive 14x, negative 8x. So when I combine positive 14 with negative 8, I do get, so again, if we have to go off to the side, we can. If we still can't do this in our head, positive 14 and negative 8, well, that makes 6. And that's a positive because I have more positives than I do negatives. So therefore, positive 14x, negative 8x makes positive 6x. So those are now gone. I also did get rid of, I combined this negative 17 with this 12. And now I get to combine the numbers that don't have a variable, my like terms. Those are called the constants, negative 3 and negative 9. So negative 3 and negative 9, if I was combining negative 3 with negative 9, that's 3 negatives, that's 9 negatives. That gives me a total of 12 negatives. This is simplified. There's nothing else I can do. I cannot combine y's with x's. I cannot combine anything without a variable with anything with a variable. So this is a completely simplified expression, and it just looks a lot more simple than the other one that we had. So for here, I am done. And this would be my final answer. There's nothing else I would have to do. I cannot simplify this any further. This is what you would write down as your final answer. Okay. Now you might have to see some word problems. And these word problems will have different things, and we might have to simplify those as well. So Jill and Kyle got paid per project. Jill is paid a project fee of $25 plus $10 per hour. So for Jill, I'm going to write that off to the side here. She knows she has $25 for the fee, fee plus $10 per hour. I'm going to write that as H for hours. $10 per hour. That's when we do it as multiplication. That word per means multiply. Kyle, I'll do Kyle right here, is paid a project fee of $18 plus $14 per hour. Write an expression to represent how much a company will pay to hire both to work the same number of hours on a project. So I want to know if a company hire both these people to do the same project together. That means we're going to add them together. So I'm adding Jill with Kyle. So this is where, again, I want to combine my like terms. Well, if the company hires them both, they got to pay Jill $10 an hour, and they got to pay Kyle $14 an hour. Well, so then that means they got to pay a total of $24 per hour when they combine the two. And then when we look at 25 and 18 for their flat fee, they're also paying whatever 25 plus 18 is as a flat fee up front. So 25 plus 18 is 43. So this company is going to have to pay a $43 flat fee to cover both of them, and they're also going to pay a total of $24 per hour to cover both. This would be my final expression to represent how much they would have to pay for both Jill and Kyle. So we're combining our variables together and combining our constants together, the values without the variable. There's nothing else I can do. It just depends, because now I have to know how many hours they work in order to simplify this. Okay, things to remember. I would write down combine like terms. Okay, you definitely want to combine like terms. And then, so that would be like 4x plus 2x equals 6x. I don't know why I put a parenthesis in front of that. Let me take that away here. That's an example of combining like terms. Okay. And then I would say, I mean, really, that's kind of, that's the big piece right here. We're just really combining like terms. Okay, maybe doing another example of combining like terms. So here, down here for your independent practice, please make sure you work on both of these problems. See how you do. And we'll check that tomorrow when I see you guys next, okay? So very good work. You didn't do, I don't know what work you did, but thank you for paying attention. Thank you for listening. And hopefully you paused. Hopefully you tried some stuff. Hopefully you got all the notes down. And we'll get some more practice on this, okay? So thanks for watching. If you have any questions, don't hesitate to ask. Gradius out.